Hello students and respected parents, I welcome you all to the perfect fusion of traditional and digital education system, Charvik Academia. I myself, Mahesh Patel from physics. My subject is physics. I am going to tell you few concepts in the physics now. Okay, so let us start and learn few interesting concepts in physics. We are starting with the concept of centripetal force. Okay, what is centripetal force? Fine. Something, otherwise anything that revolves required a force to stay on a circumference. Listen me carefully what it says. Anything that revolves requires a force towards the center. See, towards the center we require force if we want to revolve on a circle. To revolve, anything that revolves, listen me carefully, anything that revolves requires a force towards the center. That is known as centripetal force. Centripetal force. For example, suppose there is a particle of mass m that is revolving over a circle of radius r, and this be a particle of mass m, the center, and this becomes actually the radius r. Now as it revolves, as it is just revolving over the circumference, it experiences a force towards the center. That force is known as centripetal force. See, that force is known as centripetal force. Actually, centripetal force binds the particle towards the center and allow it to revolve over the circle. See, the most important factor I should have said you is, see, a force, centripetal force. Listen me carefully, we are discussing about the centripetal force. Okay, a centripetal force binds the particle towards the center and allows it to revolve. It means if you want to revolve on any circle, it requires a force, and that force is centripetal force. Centripetal force acts towards the center. Now the most important factor, how do we calculate that centripetal force? Okay, so there is a single formula to calculate the centripetal force, and that formula is mv squared upon r. This formula gives us the magnitude or the value of the force which is acting over you while you are revolving over the circumference of the circle, right? This is the formula. This is the factor that is giving us the magnitude or the value of the force that keeps us revolving over the circle, or a required amount of force that is acting towards the center to revolve over it, right? So this is what about the centripetal force. Now listen me carefully, there is another part of this formula. See, otherwise this discussion, there is another force we know as a centripetal force, that is we already have discussed it here, that is a centripetal force. But look at that formula closely. See, the mass of the particle which is revolving over the circle, very easy we say it's a constant value. The radius of the circle over which you are revolving is also a constant value, means mass and radius are going to be the constant factor. The thing that varies, the thing that changes is velocity. It does mean that F depends on velocity square. F is proportional to velocity square, right? So there is another factor of the same force, that is what I am writing here. See, if we say F is equal to mv square upon r, mass and radius are being a constant factor, so they are not going to affect you or the particle that is revolving over the circle, right? Fine. But the velocity that plays an important role. See, there is another force that is known as centrifugal centrifugal force. See, this is a centrifugal force which acts radially outward. It throws you from the circumference of the center. The force is acting radially outward, right? Now, who will decide and how do we decide that which is centripetal force and which is centrifugal force? Remember, see, centripetal keeps you towards the center, that force keeps you towards the center, binds you towards the center, and that throws outside the center, right? Okay, under the effect of centrifugal force, you will be thrown out of the circle. Right? That is centrifugal force. But listen me carefully. See, who will decide? Because a single formula works for both the case. Either you are binded to the center or you are thrown out of the center, but two factors are constant. Now, the most important factor comes here. See, if there is a value of velocity, see, there is a fixed value, there is a certain, you can say certain value of velocity which produces centrifugal force, centripetal force towards the center, right? There is a certain value of velocity. Up to that value, you are experiencing a centripetal force which is towards the center. Listen me carefully. Up to that certain value of velocity, you are experiencing a centripetal force. If you exceed the value of velocity, the force will be converted into, listen me, the force will be converted into centrifugal force. It does mean that the certain value, up to the certain value, your force will be centripetal. If you exceed the value of velocity, then it will be converted into centrifugal force, and with that velocity you will be thrown out. Let's take a certain example that is very easy to understand. I need some space, so I'm just clearing a few area out. Okay, so just taking just two lines out, right? See, fine. Now let's take the better example that you must have felt in your day-to-day life. Suppose you are actually going from one city to another. You must have passed by the highways, so you must have seen such things that suppose there is a straight line and then the curvature comes, okay, over the road. See, this is the road, right? Now this is where the curvature started. You can just draw the circle. Imaginary circle is right there. This is an imaginary circle over which the particle is expected to revolve. Especially your vehicle is considered a particle that is revolving over the circle, right? And this is what the center of the circle is. Fine. Now when your vehicle is just moving on the road, okay, it is a straight line motion. When it comes over this boundary, when it just enters into this region, your vehicle and the passengers sitting inside is experiencing a force towards the center. That force is a centripetal force which keeps the particle towards the center. Okay, the mass m and the radius of the circle is considered. Now, under the effect of that centripetal force, you complete the entire curvature successfully, because on every point of the curvature, until you go out of the curvature, until you go out of the curve, this keeps on acting on you. Like this is a centripetal force, these are the directions towards the center which allows you to take the turn. See, listen me carefully. The vehicle takes a turn under the effect of centripetal force, okay, and that is written right here. See, there is a certain value of velocity you must have seen on a triangle board right here. See, if it is written so that 40 km per hour, it does mean that you are allowed to move over this road with 40 km per hour only while taking a turn. Because this is a certain value of velocity that is required to create the centripetal force. Okay, there is a centrifugal force, and that centripetal force will be created with 40 km per hour only. If you exceed the value of 40 km and if you have started moving with 45 km per hour, then believe me, my friends, if you exceed the value of required, otherwise certain value of velocity, your force which was centripetal, now exceeding the value of velocity will be converted into centrifugal. In this case, your vehicle will start experiencing a force on a radially outward sea, because centrifugal force throws you out of the circle, means your vehicle will start moving, otherwise experiencing a force on an outward direction. Therefore, there are chances for your vehicle to be thrown out of the circle and move into the tangential direction. So whenever there is a signboard just says something 40 km per hour, just believe me, it is the velocity that would have created the centripetal force. You need to move this velocity because your vehicle requires a centripetal force, because you want to stay over the road, over the circumference, and complete the turn. In completing the turn, you need a 40 km per hour, which will help you out in creating a centripetal force, will bind you toward the center, and successfully you will take a turn. But if you just try to move, exceed, otherwise just go beyond the value of the assigned velocity, then 45 km might be the fastest value, otherwise the faster value than required. Then your force that was centripetal, which was keeping you towards the center, will throw you out, because now your force has become centrifugal. So in such cases, you might experience, otherwise you might undergo the larger accidents. So it is not advisable to go beyond the value of the signboard, otherwise the velocity that is written right here. So there was an interesting example I have written here, okay, that describes the basic physics, otherwise the concept of physics in day-to-day life, right? So there are so many otherwise very interesting examples I have within, not only for the centrifugal force or centripetal force. You can see, otherwise I can help you out in observing the physics in day-to-day life. Every part of the physics I can bring the examples from day-to-day life and will show you. See that here the physics is. In every move you are making in a day-to-day life, I will make you see where the physics is, right? So to learn the basics of physics or the interesting examples of the physics, you just have to visit to us as soon as possible. Please come to us, to the Charvik Academia. I just welcome you everyone from the family of Charvik Academia. Thank you for listening carefully. Have a nice day.
Dear students, hope you all like the demo lecture on one of the most important concepts of this subject. But don't be sad, this is not where we have finished. This was just a drop from the ocean of Charvik Academia. Explore this ocean with our team of experts and be the master of your subjects, right students? Let's have an insight into what Charvik Academia has to offer. Number one, quality education. Whether it's traditional or digital, by our highly experienced faculties is delivered very well. Number two, exclusive live doubt solving sessions is there also. Periodic test series for strong concept foundation. From 6th to 10th, we have also a foundation batch where you build up your strong foundation for 11 and 12, right? You might ask, what is the new offering from your side, right? So here is where our uniqueness comes into play. you will get the HD video recording of all the lectures, doubt solving session, whether it's conducted online or offline during your academic year. Listen student carefully, whether it's conducted online or offline during your academic year. Throughout your academic year, all the lectures, video recorded lectures available in your account on our sites, right? And second most important point is, I explain you. Student, as you know, the assessment is most important in education, for which we have an exclusive test conducting system with in-depth analysis. Whether your exam is online or pen paper based, check my words. Whether your exam is online or a pen paper based, we have unique in-depth analysis system for both this exam system. With this, students, we are offering free 7 days demo lecture whether you join us online or offline. So hurry up, limited batches are available. The early birds gets the worm, right student? So please join Charvik Academia as soon as possible for your better future and better education. Thank you.